Okay, we are on 3-5. This is 5 homework problems, but they are proofs. I think they're proofs. Oh, not all of them are proofs. Okay. 2, 5, 6, 7, 8. Those are, some of them are proofs. Some of them are proofs. Okay. All right. On to the first page. Front side of 3-5. Flip to the front. First page. Proving segment relationships. Okay, we've got segments going on. Be quiet. Okay. Segments. What they're probably going to do to you is like way back when we had like A and B and C, and they would say that C is the midpoint. And they would say the distance from A to C is 2x plus 4, and the distance from C to B is 14. I have no idea. Right? And then they would say solve for x. X is 5. Okay, if that's the midpoint, what do I know? This length is the same as that one, yeah? So I can set those two equal, and then I can solve for x, right? Subtract the 4, divide by 2. Some of you guys did that in your head really, really super fast. Okay, this is proving segment relationships. All right. Okay, segment addition. Segment addition. You are adding segments together. Ready? Let's go down to here. If they have a segment, regardless of whether B is the midpoint. Are you looking at this diagram? Jace, stop. That's bothering me. This is not necessarily the midpoint. Okay? B is not the midpoint. But regardless, let's say they give me that this is 2x plus 4 and this is 12 or 14. And they say the whole thing is, I don't know, 50.
2x plus 14 plus...
Yeah, these are no longer equal to each other now, right? But they add together. It's segment addition, right? 2x plus 4 plus 14 is equal to 50, right? And then we solve, okay? That is called something called the segment addition postulate. All right, now, what do they do if we don't have numbers? This is how you use segment addition postulate in a proof. Ready? Okay, if they give us this diagram, if they give us this diagram, what we are able to say is that AB plus BC, those are the two smaller parts, is equal to AC. This is the piece, this is the stuff that would go on the statement side of my proof, okay? And then the reason side, what do I put on the reason side? Segment addition postulate. That was what would go on the reason side. So statement side, reason side. Got it? We're proving that those things are true, right? That's what it would look like in a proof. All right, let's do this proof right here. Ready? Go. Example 1. Flip to example 1. All right, again, they're giving us like blanks to fill in. All right, let's look at this segment right here. We've got like 3 pieces that are adding up to be a full piece. Got it? Okay, here's stuff that we know. We know that QT, which is this full length here, is equal to RV, which is this full length here. Got it? Those 2 pieces are the same length, right? But then they say that we want to prove that this guy is the same as that one. Does that logically add up?
Nope.
If this chunk of 2 and this chunk of 2 are the same, how is that one the same as that one?
It just is.
Like this is the same as itself, right? Like they share that middle piece, okay? So like let's say that this is 10 and this is 10, right? How long do you want RT to be? 8? Sure, right? Doesn't it, like 8 is going into this, so that has to be 2 and that has to be 2. Like logically, that's how that works, right? Okay, so here's what we're doing in the proof. Follow along with this. We have to start somewhere. We always start with the what? Given. We have to write the given down. We have one piece of given information. Got it? QT and RV, those are the same. All right, now, this is a little piece that doesn't quite make sense. It was kind of like yesterday with the substitution thing, whatever, all right? And we did kind of talk about this yesterday. I'm going to get rid of this congruent symbol, and I'm going to just reduce it down to just be equal, okay? So now we're not talking about those things being the same shape, same size. We're talking about the measures being the same, right? QT is equal to RV. All right. That is what's called the definition of congruence. Do you see definition of congruence back here? No. Yeah, because definition of congruence is taking 6 to 7. Do you see the difference between 6 and 7?
Is that the same as
They're going from equal to congruent versus congruent to equal, right? Definition of congruence does that, all right? I don't want to have to write the congruent symbol every time, so I reduce it down to say equal. Whatever. Okay, now, they write in part 3, and it has 2 pieces. Do you see the semicolon right here? That means I have 2 things, and those are both meaning the same thing for my reason, all right? So they say that QR plus RT is equal to QT. Do you see that? That's this part right here. QR plus RT equals QT. And they also say that RT plus TV equals RV. Okay, what's that called? What's the reason for that?
This one's like the thing that we did, the law.
substitution?
Segment addition postulate, right? The 2 smaller pieces added together make the bigger piece. This is segment addition postulate. I'm just adding segments together, right? 2 segments added up make the full segment. 2 segments added up make the full segment, right? Okay? All right, now. They don't have, part 4 is going to be the hardest part. What do I do with that information? At this point in my proof, I start combining stuff. So like, how can I use this and this to my advantage?
taking everything away.
QT shows up right there, right? QT is there. So can I take this guy and like this part and shove it in place of QT?
Yeah.
Okay, so I'm going to do that. QR plus RT is going in place of this QT, right? Okay, in the same way, RV shows up there. So can I take this piece and shove it in there?
Yeah.
Okay, so equals RT plus TV. What's that called? What did I just do? Substitution. Substitution. Okay?
What?
I'm substituting those things in there, all right? Now, let's look at number 4. Let's look at where we were just at. We have QR plus RT equals RT plus TV. This is like combining like terms. What can I do?
Subtract the RT.
I'm going to subtract an RT over, right? Which is exactly what they did here. They just wrote it out the longhand way, right? RT, they put their minus RTs at the end instead of putting it below like we usually do, right? And that's called the subtraction property. Okay, how do they go from this big long step to 6?
Well, the RT.
They're just basically like canceling the RTs out, but what's that called? What do they call it? They call that the stupid substitution. Substitution. And now we have this, and to go from there to there, we do the definition of congruent, right? Okay? So I get from one to the other, right? That was a little bit harder of a proof, right? Logically, it should make sense that the 2 smaller pieces are the same, but proving it is a little bit harder, right? Like going through the reasoning. Got it? Like a 4th grader might not necessarily understand that like this would be the same, right? So you might have to explain it to them in parts, right? Okay? So that's how that works. All right. Let's go and do, I don't know. Let's look here. Hold on.
Okay.
We're almost done. Okay, let's look here. It's top of the 2nd page. This is called segment congruence. Okay? All right. Let's look at these things. All right? We have something called the reflexive property, the symmetric property, the transitive property. Okay? I'm going to start with the transitive property because that's something that we've seen before. Okay? Look at the 3rd one, the transitive property. All right, right here. This thing. This says if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF, right? Like I skip over the CD. Kind of like I skip over Owen because we don't care about him. Right? Do you remember yesterday or the other day where I said Trevin is younger than Owen and Owen is younger than Wyatt? So Trevin is younger than Wyatt. We skip over Owen because we don't care about him, right? Not true, but whatever. Okay? So we skip.
That's true.
Yeah, so from P to Q and Q to R, and we're going P to R, right? Okay? Well, what did we call that the other day when we did it?
I don't remember.
It's the law of syllogism.
So,
Okay, but what is it called here? The transitive property. Those are essentially the same thing. It's the same pattern. Law of syllogism for statements is the same as the transitive property. Got it? Like Trevin is younger than Owen, Owen is younger than Wyatt, so Trevin is younger than Wyatt. That's how that transitive property works. Okay, let's go to the symmetric property. You guys have seen this before. Have you ever done an algebra problem where you end up with like 2 equals x? Does that bother you?
Yeah.
because you switch it around and you say x equals 2. You know how you're able to do that? Something called the symmetric property. Symmetry means that the same on both sides, right? Something is symmetric. Symmetry, right? So 2 equals x, that means x equals 2. So if AB is congruent to CD, then I can flip it around and say CD is congruent to AB, right? Now,
You can prove that, it's just weird.
right. Like that's just a thing. Okay, now the last thing is something called the reflexive property, and this puzzles people, all right? AB is congruent to AB.
Wouldn't it be BA?
Isn't that, the reflexive property is saying the same thing as congruent to itself. Isn't that like, duh? Like, why would we have to even say that? Okay, here is why, hold on. Let me show you. Here is why that reflexive property exists. Are you ready? Eventually, we will get to the point where we are dealing with 2 triangles at the same time, right? Okay, let's say I have 2 triangles butt up against each other, and here is where AB lives, okay? I will use the reflexive property to say that AB for this triangle is the same length as AB for this triangle. So they're 2 different ABs, but kind of the same AB, right? Okay? So it feels dumb that I should have to say that, but that's part of the proof when we're proving 2 triangles are the same that are butt up against each other. Yes, we're talking about the same AB, but AB for this triangle versus AB for the second triangle. Okay? That is when we will use that a lot. Okay? Another use of that reflexive property is this. Okay? Let's say, you don't have to write this down. Let's say I have this going on right here. Okay? And let's say this is angle 1, right? This is angle 1. Don't write this down. Okay? How many triangles do I have there? It looks like a piece of candy corn, kind of.
Actually, yeah, 3 if you want to.
2.
I have 2 triangles, right? I have this triangle, right? Which is this smaller one. Okay? That smaller one. Okay? And then I have the bigger one, which is the full thing, right? Like that big one, okay? Now, they both have angle 1 here, right? But they're both 2 different triangles. Is angle 1 over here the same as angle 1 over here?
Yes.
Sure, because they're the same angle, right? So we would say angle 1 is congruent to angle 1. Well, duh, it is, but it's talking about 2 different triangles, right? Does that make sense?
Yeah.
So that is why that reflexive property is there. Yes, it seems stupid, but
To itself for a different object.
right. It's saying that it's the same as itself, but talking about 2 different objects that are like sharing that thing. Yes, that's when you use that reflexive property. We won't probably get to that point where we're using that quite yet. Okay. All right. Good.
Yep.
Questions?
Nope.
Okay. Let's do.
Number 2.
Let's do example. I don't know.
I say we just get homework.
Let's do a homework problem together, shall we?
Number 2.
Sure. Number 2. Okay.
Number 8. I don't care.
Let's do 2.
Some extra.
2 is a lot of steps. Okay. Let's do 2. All right. I'm doing homework.
Oh, 1 has more.
Ready? Let's go. Number 2 has a lot of steps. Okay. We don't have to do 1. Do you have to do 1?
No.
No, you have to do 2. Okay, here we go. We're doing 2 together. Here we go. This is our object right here. Like that's the visual. That's what we're doing. Okay? What?
They put question marks where we're
I don't know. You just write over top of the question mark. It'll be fine. Okay. All right. Ready? Those 2 line segments. They look about the same length, but we don't necessarily know that they are. We'll see, right? Okay. Let's look at the given though. This says SU, which is this full length of this top one, is equal to LR, which is the full length of the bottom one. So are those 2 segments the same? Yeah. Okay. And then they say TU, which is this little piece, is the same as LN, which is this little piece, right? True? Okay, that's true. They want to say, okay, if those 2 things are the same as each other, then ST, which is this guy, is the same as NR. Can we prove that?
Yeah.
Does that logically flow that that should be true, right? Okay, let's break it down. Let's figure out what we're doing here. Okay,
Let's prove it.
number 1. What goes on the reason for number 1?
Given.
It's given, right? That's always given. Now, I have had people come to the test and they're like, oh, given. If that's given, then the bottom one must be prove.
No.
The bottom one is never prove, even though like that's how that works up at the top, okay? The top one is always given, but the bottom one is never proved. Does that make sense? Okay? That's not how it works. You never, a reason is never prove, right? That's not a reason. Okay, so given, we have the top, that's given. Okay, definition of congruent segments. What is that? So we switch from congruent to equal. Okay, we just pull off the congruent signs and we put equal. TU equals ln. Got it? Okay? All right, now, they went in step 3 and they said, okay, this is their logic, or this is what they did. Let me get out of here. Okay, they said that SU is equal to ST plus TU.
Yeah.
What's that called? The two
Segment
smaller
item
pieces, the
postulate.
two smaller pieces add together to be the bigger piece, right? That's the segment addition postulate.
Can we abbreviate it to SAP?
No, just write segment, just write what I wrote. Segment addition postulate. Okay? Now, in the same way, they did it under the same step. Shh. I'm literally doing your homework for you, and I will stop if you don't listen.
Substitution.
Okay. LR is equal to LN plus NR. Does that follow also segment addition? You're adding segments together. Got it? Okay. All right, now, let's go from 3 to 4. Like, how do I get from 3 to 4? Okay, in step 3, I see ST plus TU. They put it here. And LN plus NR, they put it here. How do I know that?
Substitution. Right?
In the step before it, I said SU equals LR. So I took this guy and put it in for SU, and I took this guy and I put it in for LR. Yeah? That is called?
So then it would be
That is called
inclusive property of
hold on. That is called substitution. You stay with me. Substitution. I'm plugging stuff in. Okay, now, what's the difference between 4 and 5? Like, what did we change?
Places.
Yeah, you replace the T with the ln.
We replaced TU with LN. How am I able to replace TU with LN?
Because they're.
TU equals LN, right? So I took LN and I plugged it in for TU, right? So what's that called? Another substitution, right? Okay, all right, now we're here. Now, what did they do going from 5 to 6?
They subtract the ln.
They subtract the LN. What's that called?
The subtracted.
The subtraction property. Okay? All right. Now, they said substitution for the next one, but that's like code for
For reduce.
reduce, right? So ST is equal to NR. Okay, now how do they go from 7 to 8? They did definition of congruent. And I'm going to write the symbol so I don't have to write out the word congruent, right? Good definition of congruent just takes the equal sign and puts a congruent in there, or vice versa, right?
So is definition
Okay.
of congruent segment the same as definition? So where's the proof then?
What?
So how are we supposed to do number 6?
What you talking about?
Okay, is definition of congruent segment the same as definition of congruent?
Read it. Draw a picture.
Okay,
Then
go
I'll
back.
help you.
I'm going to fetch water.
Read it, draw a picture, then I will help you if you still are
Let's
stuck.
get water now.
Okay? All right. Use the rest of the time to do the other
Can I
4.
get water?
Can I go down to kindergarten?
Yeah.
Can I get water now?
I'll be back. I'm going to get a short.
All right. Goodbye.